Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy them, so check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, you've got everything you need to run a fast, reliable, and bulletproof data platform. And for your machine learning workloads, they've got dedicated CPU and GPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, ODSC, and Data Council. Upcoming events include the Software Architecture Conference in New York, Strata Data in San Jose, and PyCon US in Pittsburgh. Go to dataengineeringpodcast.com/conferences to learn more about these and other events and take advantage of our partner discounts to save money when you register today. Your host is Tobias Macy, and today I'm interviewing Joshua Beemster about how Snowplow manages deployment and maintenance of their managed service to their customers' cloud accounts. So, Josh, can you start by introducing yourself?
Sure. Pleasure to be here, Tobias. My name's Josh, and I'm the technical operations lead at Snowplow. I've been heading up that role for the last 3 years. I've been working with Snowplow for the last 5. Yeah, I'm responsible for all the cloud infrastructure and maintenance across our currently 150 plus clients.
And do you remember how you first got involved in the area of data management?
It was a little bit by accident, honestly. So I started at Snowplow as a data engineer and kind of expressed quite an interest in automation and kind of getting rid of repetitive tasks. So kind of naturally moved into infrastructure management, and yeah, just kind of went from there.
And so, can you start by giving a bit of an overview of the overall components in the system architecture of Snowplow and a bit about the nature of how you deploy and maintain the managed service that you offer?
Sure. So I think this one's probably best to start with what the nature of the managed service is first before jumping into system architecture. So what we offer is essentially what we've coined as private SaaS. So what we mean by that is that it is a fully managed service, but it's isolated in a client's own sub account. So essentially what that means is that each client comes to us and gives us their own sub account, their own Google Cloud project, and we set up and maintain a full data pipeline stack within that sub account. So every client has their own isolated infrastructure, entirely segmented from every other client. So it's SaaS in that we manage everything end to end, and we're responsible for all of the running of it. But it's very much not SaaS in that there's no shared tenancy across anything there. That's obviously quite a difficult thing to manage. In terms of what that means from a system architecture, on our side, we have a lot of tooling that we've built to manage that, which leverages heavily the Hashi stack. So we're using a lot of Terraform to create all of our infrastructure as code. We've got HashiCorp console to manage all of our metadata and Vault to manage our secrets, and then Nomad to do that widespread distribution of deploying all of that infrastructure. So I guess it's different in that sense. There's some parallels, I guess, with companies that would offer you to buy a license to their software, and then you would go away and deploy it yourself. And we, I guess, take that a step further, where you're not only buying the license, you're buying the whole stack experience.
And for people who want to dig deeper into what Snowplow itself is, I'll add a link to the interview that I did with your co-founder, Alex.
Yep.
But at a high level, it's a event data management platform for being able to replace things like Google Analytics or Segment. And so in terms of the private SaaS nature of your product, what are some of the challenges that are inherent to that deployment model that you're trying to overcome with some of the tooling and automation that you've built out?
So the obvious one is that rather than having one big data pipeline to manage, we have 150 of these. And rather than being in one or two or three regions across the world, we're in kind of every region of the world. So there's difficulties first off with just the sheer number of servers that we are responsible for, numbering in the tens of thousands. And with quite a small SRE team, that is a big challenge in and of itself. With threats like at the start of last year we had Meltdown and Spectre and all of these kind of scary security concerns. We're suddenly going, well, we're responsible for all these servers. We have to go and manage that. So that's a big challenge for us in terms of staying on top of all of these systems and making sure that they're always up to date. The other side of it though is just how much automation we need to build into it. There can't be anything that really requires any manual interaction or any manual intervention. We have to go top to bottom. Everything must be self-healing. Everything must be able to automatically recover, because otherwise we just can't scale our operation at all. Specifically though on kind of managing clients in this context, there's obviously a sharp change in dynamic where in normal SaaS you wouldn't get to see the underlying infrastructure. You wouldn't get to see how things have been set up. You wouldn't be able to go and poke around at any of these things. And what we've had with quite a few clients is that they dig a little bit too deep, or they go and change things that maybe they shouldn't have, or they go and break things that maybe they shouldn't have. And those are quite difficult for us to manage, because obviously we've gone and deployed something and we've deployed it in a way that we expect it to work, and then someone else has come in and turned something off or broken something or changed our access, whatever the case might be. So there's those, trying to balance that is quite difficult. So we've got a lot of constantly checking for any drift detection style systems to make sure that nothing has changed and everything is staying exactly as it is. So there's a lot of those challenges with, I guess, what you call a shared responsibility model between us and the client in terms of managing that sub account, which we do struggle with sometimes. The other interesting things with private SaaS is just how auditable and how exposed it is. So as we work with more security conscious clients, we do end up getting audited a lot, and we have a lot of very long conversations about how things have been set up, how things need to change to suit their particular business needs, and where normally you'd go and buy a service and you're not too worried about exactly how they've instrumented. Suddenly when we're deploying inside the client's ecosystem, we have to fit their checklist. We have to fit all of their security concerns. We have to pass muster with their security teams, with their SRE teams, to make sure that everything is exactly how it needs to be for them. So we've got a lot of challenges there, not only in managing and orchestrating and running the whole thing, but also just getting sign off for a lot of these teams. And is this up to spec? So we have a lot of extras added into the platform as we have these conversations that we have to adjust and manage in such a way that it is still scalable, it is still going to work for everyone, but we have to add lots of extra things on the fly.
And because of the fact that you are running in the customer's account, I'm sure that there's also some measure of cost consciousness in terms of the bill for running all these different resources and handling scaling and trying to minimize the amount of resources that are necessary to keep this running, because in a SaaS, the provider eats all of those costs and just passes that on in terms of the cost that they charge to the end user. But because the end user in this case is running all of this in their own infrastructure, they're much more cognizant of the actual overall cost of running all of these pieces of infrastructure. And so I'm wondering how you handle minimization of the resources necessary while still allowing for robustness and scalability in the platform that you're deploying.
So that's a really pertinent question. It's a great one to raise. It's a bit of a balancing act. We do have kind of hard rules that we don't want to breach when it comes to deploying a production environment that we do get sign off from the client from. So, for example, you've got a production environment, it has to be highly available. So you have to have a minimum of 2 availability zones. You need to be setting up enough servers that if a catastrophic data center failure happens, that happens. So there are carve outs to say there's a minimum spec for what this looks like. But beyond that, the architecture is flexible enough that we can save cost in a lot of ways. So we work quite closely with clients on how we do instance reservations, how we right size pipelines, how we right size it for their particular traffic patterns. So there is a level of customization and work that we have to go through to make that happen. On the whole, though, we've we've come to a good level of, I guess, what are the minimum things that we need, and that's where we sort of start. And as clients ramp up traffic, we then tend to have the harder discussions around, okay, to make sure that this is stable at these volumes, we're going to have to massively upscale Kinesis, for example, to make sure that there's no back pressure issues, or you've got a 1 second latency requirement, which is going to require these sorts of changes. So every client is different in that sense. Some of them won't mind there being a bit of latency buildup in their pipeline, and then we can size it down for cost. Some are very, very latency conscious, but far less cost conscious. So it also, in that sense, comes down to what is the data, what is the value of the data for the company. If it's just a report that runs once a week, we can definitely optimize for cost. If it's something that needs to be run every second, then we need to optimize for performance. It's very conversation heavy topic with clients that we find. There are obviously blanket strategies. Instance reservations are a classic one. Turning off certain parts of the service as well. It being quite a modular data pipeline where you kind of plug in different exports. For example, in the real-time pipeline that we deploy on AWS, you can send data into Elasticsearch, you can send data into S3, you can send data into Snowflake DB, you can send data into Indicative, you can send data into Redshift, but you don't have to pick all of these targets. So we also work with clients to figure out, well, what is the best way for you to consume this information, and then setting up their pipeline accordingly. So they're only paying for what they really need. But you're exactly right that the fact that it is running in their sub account, they do bite that cost. On the flip side to that particular point, though, is an interesting one, which is that none of our clients really have to worry about volume-based pricing in the same way as you would with a competitor like Segment, for example, or any of the other SaaS analytics providers, which are volume-based pricing. So with Snowplow, as you scale up, as you track more, your costs are not going to drastically increase. They will increase linearly with infrastructure costs, but there isn't kind of an exponential cost growth that comes generally with volume-based pricing.
And then another thing that's interesting about your model is that shared responsibility that you mentioned of, because the servers are running in the client's account and they have their own way of managing infrastructure. I'm sure that there are some instances where you have conflicts as far as how they would prefer to handle deployments where they have their own infrastructure automation and configuration management. And then on the monitoring side, I know that you keep track of the health and well-being of the overall system, but I'm sure that the customer is also interested in being able to consume those metrics into their own systems to get visibility. So I'm wondering how you handle that aspect of the responsibility being on your end to keep everything running, but at the same time, the customer wanting to have greater visibility and tight integration with the systems that they already have deployed.
Yes, that is a really common theme. On the monitoring side, we do tend to leverage on Amazon CloudWatch and on GCP Stackdriver quite heavily to alleviate that to some extent. So rather than figuring out how do we pull all of these metrics in and turn them back to the client in a nice reportable way, we leverage the cloud's own tooling there, and then provide kind of easier ways for them to hook into SNS topics for getting all of the same alerts that our own ops teams get, so that they can look at that. But also, by virtue of the fact that it's in their sub account, they can explore any metric that's exported to those systems, and that's where all of our metrics live, is in those systems. There's very little bespoke monitoring, so to speak, that's coming only to us, that only we have visibility over. So on the monitoring side, that's mostly handled now, which does make our life easier. On the customization side, or kind of we're not fitting the perfect mold, that is often fairly difficult. There are times that we do need to develop more custom solutions, and which we'll do kind of on an ad hoc basis. The difficulty for us in offering any sort of bespoke solution, though, is that we are running it across 150 different stacks. So the name of the game for us has to be consistency across the client base. So what ends up happening is that as clients have more security requirements, it becomes part of the kind of standard that we make available for everyone. So any feature that we develop for one is developed for all. And in that way, as we go, we'd end up being able to tick more of those security boxes without necessarily having to do something bespoke every single time. And in a lot of cases, we do manage to convince them that making too many changes is not always necessary, and that we can kind of have that shared responsibility where we run things how we need to run them without needing to change everything. We're yet to come up against someone that really won't let us work how we want to work.
And another element of customization is the fact that the overall Snowplow pipeline is very composable, and different components within the stack can be swapped for some equivalent system. For instance, the Kinesis that you would run in an AWS account might be replaced with Google Cloud PubSub in a Google account, or if somebody's already running Kafka or Pulsar. And so I'm wondering how you approach that aspect of customization and allowing the customers to be able to specify how they want different elements of the system to be manifested based on their preferences or what they already have running, to allow for better integration with the data systems that they might want to integrate with.
With the managed service that we offer at the moment on GCP, we only support PubSub, and on Amazon we only support Kinesis. So for that core part of the pipeline where we're kind of collecting and enriching and kind of storing that data, there's not a whole lot of flexibility just yet in terms of the fact that we have to own and have a standard part of the pipeline that is the same for everyone. Where we allow a lot of flexibility though is what you can plug into the pipeline on top of that. So for example, if you've got a big internal Kafka cluster, what we see a lot of clients end up doing is streaming all the data that we place into Kinesis into their own Kafka cluster to do larger fan out operations, which Kinesis doesn't support as well as Kafka might do. The key issue there, though, that's worth touching upon is not that we don't want to support, loading into someone else's data stream, is so much that we support SLAs on the latency of data into those data streams. And if we have a third party dependency that we can't control, that's very difficult to meet. For example, if a client did want us to load directly into their Kafka cluster, but we had no authority over said Kafka cluster and they had a massive spike in traffic, there's no way for us to really account for that. There's no way for us to go and say, hey, we need to increase the size of your Kafka cluster because the pipeline can't keep up. So there is a certain need for a separation of concern there as well, so that we can ensure the health of the pipeline. And having too many external dependencies or any external dependencies makes that exponentially more difficult, not only in terms of making sure that the pipeline is working, but even just debugging why something's happening becomes harder because you're not in control of the entire fabric, the entire system. So core part, very, very locked down to what we support, and we very much want to be in control of that. But yeah, as I said, forking off the pipeline into other systems is definitely something we see a lot of. So writing custom Lambda functions or Google Cloud functions, or streaming that data with Kinesis to Kafka connectors are quite common patterns to kind of push that data into new and different places. And we obviously also have our own analytics SDKs that can plug in on top of that stream to then do custom mutations before sending it somewhere else as well.
And so, in the overall system, which components are the ones that are most subject to variability in traffic or resource pressure? And what are some of the strategies that you use to ensure proper capacity, as there might be burstiness in the events that are being ingested, or being able to meet some of those latency SLAs that you mentioned?
So obviously we leverage a lot of auto scaling to account for that burstiness, but not everything is auto scaling. So what the biggest issues that we come up with in terms of dealing with that burstiness is generally to do with how fast we can get new EC2 nodes online. But generally, it's with the few non-auto scaling components within the pipeline. If we take GCP for an example, we're using PubSub there. Now, PubSub is this beautifully elastic auto scaling system where you can throw as much as you wanted it and it will scale to meet demand without any issues. Where we run into issues is on the flip side in how we run AWS, which is using Kinesis, which has kind of fixed size, and Kafka or Azure Event Hubs would have kind of the same sorts of issues where you've got much more fixed kind of sharding based ingress limitations. There's kind of two ways we tend to tackle that. One is with, so we've built our own sort of proprietary auto scaling tech that kind of goes and does reshards of Kinesis as and when needed, but that tends to fall over quite quickly at higher sharding rates. Where I'm talking, if you're getting into the 100 or 200 plus shards, doing a resize can take anywhere up to 35 minutes, which is often far too slow for a very big burst in traffic. So in these cases, we tend to work with clients and look at their traffic patterns and look at where they're going to be evolving up to. We do quite a bit of trend analysis there, and then we can say, well, if you want to keep the pipeline healthy, we're going to have to get this much of a buffer in place for this non-auto scaling component. Otherwise, we're going to run into issues that are not going to be recoverable very quickly. This is obviously not the best strategy. Instead of having a nice auto scaling elastic architecture, you've suddenly got hard coded capacity, which means that we have to have an around the clock ops availability to check for alerts, check when we're starting to reach those thresholds and go and scale that up. We're kind of actively looking at alternatives at the moment for kind of how we can swap out those systems for something a bit more pub sub-esque, especially on Amazon. We're looking at, so how could we maybe swap out Kinesis for SQS and SNS for that similar sort of elastic auto scaling queuing with fan out, rather than leveraging something like Kinesis. So that's in the streaming side. That's probably the biggest bottleneck. The rest of it all is quite easy to auto scale, and it's generally quite fast. The other areas we have issues is then with downstream data stores that are by nature a lot more static in size. So Snowflake DB in a lot of ways has solved that, and BigQuery obviously has solved that as well, where it's kind of unlimited storage capacity. You can just throw whatever data you want into there, and it's backed by blob storage. So you have your data lake in that sense. Where we then run into some issues, which Redshift is starting to address with their new instance types that they've released, but Redshift and Elasticsearch still serve as a weak point in the architecture, because there is capped capacity. And especially when you're looking at a streaming pipeline and you want to stream data in as quickly as it's arriving, big spikes in traffic can overwhelm CPU resource. They can overwhelm suddenly the amount of provisioned, capacity that you have for these systems, which can cause service interruption and downtime. So we have, again, around the clock teams that are waiting for these alerts to go and upscale systems as and when we breach. Yeah, I guess the strategies there are to look at patterns and look at how's my evolution of tracking been developing over the last months, how has the pipeline handled spikes in the past, and then sizing it up with a healthy buffer to make sure that when these things happen again, you're covered. But there's a limit to what we can do, especially running so many of these systems, to then try to catch all edge cases, which is why we still need that around the clock ops team to deal with that.
And then another interesting point for me is the fact that you ended up going with Nomad as your substrate for being able to handle bin packing and managing the processes for all the different components that you're running, where a lot of the mind share right now is with Kubernetes. And so I'm wondering if you can talk through the overall decision-making process that led you to that conclusion, and maybe talk a bit about some of the ways that your infrastructure management has evolved since you first began tackling this problem.
So there's just a quick point of clarification there. So for the client side pipelines, where we are actually leveraging Kubernetes in the GCP pipeline, and we're looking to leverage ECS in the Amazon pipeline. So we only use Nomad internally for internal orchestration and scheduling fabric. The main reason we've chosen Nomad for that task is really just its deep level of integration with the rest of the Hashi stack. So it seemed natural to say, well, we're using Terraform, we're using Consul, we're using Vault, we're using Packer. We should use Nomad as well, because it's all the kind of nice, neat native native integrations. But on the latter point around, and I can touch on why we've used ECS as well, possibly after, but the latter point on where our evolution has happened, that's a very long history there. So where we started a few years ago, we had much fewer clients, a much simpler tech stack, and we could kind of get by with a lot of manual work. So the decisions we made at that point in time were very much, we could do a human driven approach to deploying infrastructure. We could take some measure to be, yeah, we'll put some of it in CloudFormation, and for us we'll have some checklists and we'll go through it, and we'll just kind of get things running as quickly as possible. So it all started with just Ansible playbooks that would then run some CloudFormation, and that would spin up the pipelines. When we first started writing that automation, we made a few big mistakes. We made several big mistakes. Mistake number one was not making the infrastructure granular. So where we'd be deploying a VPC and a Elastic Beanstalk stack and maybe some Amazon S3 buckets, maybe a Redshift cluster as well, we'd put all of that in one giant CloudFormation template. And at the time, that made perfect sense, right? We had one version of what we were deploying, and we'd go and deploy it. And then we'd run into all these interesting issues where you'd have clients say, well, I don't want this part of it, I only want this part of it. You go, okay, so now I've got a whole new version of my stack. So you fork that stack, and you get this version, you get this version. But then you've got all those permutations. And what we quickly realize is that what you need in infrastructure automation is not that big bang stack, but you need very, very high granularity in all the components. And you want, the same way as you mentioned that Snowplow is very composable from lots of microservices, we needed to approach infrastructure in much the same way, or even more composable. So where we are now in that journey is that we went from big bang Ansible playbooks with very large CloudFormation templates. We then moved that to a bespoke tooling system, I guess, which was still based on Ansible and CloudFormation, but had a lot of that granularity starting to appear, which worked for quite a long time, but still wasn't very flexible. And part of that was probably our use of CloudFormation, in that we found that to be a little bit awkward to work with and a little bit awkward to make very, 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 very flexible. But the key journey there was really about going from kind of low granularity to high granularity. And then we ran into a further issue, which was about state. So up until we started using Terraform, all of our deployment tools had been completely stateless. We'd leveraged essentially the fact that we were using CloudFormation, so we could just query the outputs of CloudFormation templates, or we were going and writing API calls to go and check if certain components had been deployed and what configuration they had at time. So it was all kind of just in time resolution, and that was really flexible and kind of reduced any need for us to cache or worry about state anywhere. But it also made us very lazy, in that we weren't caring about that. So we weren't necessarily making the right decisions. Then as well, every time we wanted to expand the system, we had to go and fetch all of this information all the time. And it also meant it was very hard to build a view of what had been deployed. It made it very difficult to go and write a tool that could just build a report and say, hey, this is everything that's deployed. This is current state of the entire system, because it was all stateless. So to do that was all very expensive, long API calls and checks that were just not very useful. And that system, that bespoke system, being what it was very hard to then turn into a neat API. It was also impossible to train the rest of the team on it, which I quickly discovered as I started hiring more SREs and trying to train them into using this tool, that no one could actually use it easily. So that's when the kind of next part of our journey began, which was saying, well, hey, let's throw it all out and start again. Which we started actually at the beginning of last year, and we set it on Terraform because it was kind of flexible enough to support multiple clouds, which we now do. So we needed something that could have a common instruction language for GCP or AWS, and possibly in the future Azure or any other cloud that might appear. We also wanted something that a new engineer joining could kind of deal with. They wouldn't have to learn the configuration language; they just have to learn what we built on top of it, which was a massive difference in terms of how well we could support this. And it also had all of the heavy lifting done. It had state, it had integrations with console and Vault, which we're leveraging quite heavily to build detachments and metadata management, centralized metadata management, centralized secret management that we could then feed into all of this configuration that we've done with Terraform. And as well with that, and as I mentioned previously, with our adoption of Nomad as well, we've now been able to slap an API on the front of it all, which we call our deployment service, which is very aptly named. That can then go and use this whole ecosystem to go and manage all of this infrastructure. So we've come from a human driven choose your adventure style infrastructure management tool based on CloudFormation and Ansible to kind of this world of API driven, ChatOps driven infrastructure management, which is kind of where we've gotten to now. I guess the other quick thing I'd love to touch on there as well, and that you mentioned, was that kind of Kubernetes is that the flavor of the month almost for how everyone's managing containers. I guess on Google, we did roll with Kubernetes. We did that because Google has like a fully managed Kubernetes offering, which is very attractive to us because then we didn't have to home roll our own Kubernetes, and that's also a big thing we look for in our implementation is we need minimum overhead in every way, shape, and form. We can't have too much overhead. We can't do too many custom things. When we can use a cloud tool, we use the cloud tool because that is very important for us for scaling out our operation. And for GCP, Kubernetes seemed like a very good fit. For AWS though, we're looking in a slightly different direction. There's a few reasons for that. So one is that Amazon managed Kubernetes isn't quite the same breed as the Google managed Kubernetes. You're still responsible for kind of setting up the underlying data nodes. So you still need to do. It was, I guess, a bit like when Elastic Container Service first arrived, and you still had to manage all of those EC2 servers yourself. It's not a fully managed service in that sense. You're still responsible for setting up your auto scaling group, setting up those servers, and kind of hooking them up to the cluster. So there's that reason, but as well, what I found personally, and take this with a grain of salt, is that there is a lot going on in Kubernetes, and for what we're trying to do with it, it's not that it's overkill, but it does more than what we need it to do. And by virtue of that fact, it costs more than maybe we want it to cost. In terms of, we don't need all of this advanced extra scheduling and management systems necessarily to just run a couple of pods. All they need to do is run a simple Docker container that scales up and down. There's no extra service discovery. There's no internal load balancing that needs to happen. That's all kind of done for us already. So we're looking at ECS as kind of just a very simple container management fabric as opposed to Kubernetes, which to its credit is much more powerful, but is just much more than what we tend to need for the Snowplow stack.
And in terms of your experience of building out this automation and managing this platform, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
That's a tough one. That's a tough one. I think most interesting has been, and this is kind of in the time working with clients, but just how deeply interested a lot of clients are in kind of how we're deploying it. So, and how hands on all of these teams want to be. So that's been it's been an interesting and a challenging lesson in terms of having to kind of defend your work constantly. I guess is the point I'm trying to get to. There's a lot of, if you were developing a system that was for kind of internal eyes only, you don't expect so much attention on it. You don't expect people to rip it apart in quite so many ways. So that's been a challenge in developing the stack. It's definitely a good thing to have. I think if you onboard a client and every time they kind of audit you, you can only get better. And we've seen that as we've evolved, is that it's been challenging to try to meet all of these requirements and meet all of these expectations, but that's actually worked out for the better because we've got a much better system at the end of it than we otherwise would have. And I think the other difficulty is really in just figuring out how to manage so many servers concurrently and how to monitor all of them and how to ensure the uptime of all of them. We run into a lot of really challenging scenarios with what we've deployed. One big issue is actually in kind of anything that has a sort of ephemeral nature. And one big reason why and I think there's another question coming about what things we want to change in the stack, but batch processes or ephemeral processes are much more fragile than you'd possibly imagine. And in a situation where you're one company running one ETL process per day, you probably won't run into these issues, but we often see giant cluster failures across Amazon, which is massively challenging. As we've scaled out, we've started to be impacted by those a lot more, obviously. So, for example, we might have the EMR API fail across US East 1 for a couple of hours. Now, again, if you're running one ETL job, you go, okay, I got one failure, one thing that I got to go and recover. On our side, we've got our support team, which might have 40 or 50 failures that they've got to suddenly clear and communicate out to clients, make sure that they understand what's happening. Why is their data late? Why is it not arriving in their data warehouse? So that's definitely, it's a big challenge. I'm not sure if it's an unexpected challenge, but it's definitely an interesting one to figure out how we deal with, and just how we deal with any of the scale problems, really, as kind of a small SRE team trying to figure out how we manage the infrastructure of so many clients and keep it secure and make sure that none of them are costing too much. So there's a lot of interesting challenges there that we're looking to solve in some parts with actual snowplow monitoring. So we build a lot of monitoring on top of all of these systems to kind of try to do some trend analysis, and we're hoping to get a lot more time to look at solving these challenges with machine learning to try to figure out how can we detect trends in data, how can we scale up systems intelligently ahead of anything happening so that we can provide the best possible service. A lot of scale problems.
And are there any elements of your experience of managing the Snowplow platform that you think are more broadly applicable to data infrastructure as a whole that you think are worth calling out?
Uh, I think the biggest one is probably just general rules is just your infrastructure has to be super composable. It has to be as granular as you can make it. If you want to be able to evolve it quickly, if you want to be able to change things quickly, if you want to be able to attach lots of different pieces together, start it very composable. Don't big bang an infrastructure stack that will catch you out very quickly. So I think that's probably the biggest learning I've had, and also kind of how you scope your resources. So making sure that you're understanding, is it regional contracts, global contracts? How you group things, how you manage your different infrastructure resources. I think from kind of just managing data pipelines, getting a clear understanding of what you're tracking, why you're tracking it, and how much data you're expecting to collect or want to collect is incredibly important. Making sure that you kind of design it for purpose. I think going too generic with with what you're building doesn't really help, but really thinking about what's the end goal here. So, for example, within our own kind of internal pipelines, we've got an ops or monitoring pipeline that's really streamlined for dealing with lots and lots of small metrics. And we've got our kind of business pipeline, which is more geared towards our longer term analytics of our website and those kind of things. So figuring out what structure you need to serve the business is also really important.
And if you were to start over today with all of Snowplow and the infrastructure automation that you're using for it, what are some of the things that you would do differently or ways that you would change some of the evolution of either the Snowplow pipeline itself or the way that you've approached the infrastructure management?
So I won't speak to the kind of the overall snowplow components, but for the infrastructure side of it, I think the biggest I think we'd probably not go for using something like Kinesis, or we would have approached it very, very differently. I think we would have leveraged something that is truly auto scaling. That's probably one of the biggest infrastructure problems we have at the moment is Kinesis and its lack of elasticity. It does cause us a lot of heartache, causes a lot of heartache. And I think beyond that, in terms of managing the infrastructure, where we are now is pretty close to where I wanted. And as I mentioned, we did rebuild the entire system last year, so that was with kind of a lot of years of learning, going, how can we do things better? How can we do things differently? I think if I could though take go back to the start of last year and take a slightly different tack, I would go even more granular in terms of the stack separation and the topology of infrastructure that we've built. We've still gone to Big Bang, which is making it quite hard to evolve certain parts of the infrastructure stack that we're trying to manage. So we've coupled components together that should have been split apart. We've made it quite difficult for ourselves, and we're going to be paying for that in the near future. How do we unpick some of these associations, and how can we make it more flexible again? And that's really a problem that we suffer from, just because we have so much variance in what our clients want. So there's not kind of one pipeline. There's pipelines of lots of different pluggable components. There's needs for having maybe multi-region support, multi-cloud support for kind of syncing data into a single pipeline. Really custom fabric, custom ETL systems that are required. Which just the more granular we are, the easier that would have all been. And not that we've coded ourselves into a hole, but we do have some work to kind of make it that much more flexible again. But that's really, I guess it's just a learning as we go, that we just need to be super flexible, because every client's going to have different wants and different needs, and we want to be able to serve them all, but in a manageable way. And that's difficult if you've only got one version of what you can set up.
And what's in store for the future of the Snowplow product and the way that you're approaching management of the service that you're providing for it?
So hopefully coming soon, and I hope the product team won't get upset at me for saying any of these things. What I'm hoping for quite soon is that from our managed services UI, we'll be able to start managing infrastructure directly from that UI. So at the moment, the way customers interact with that, they have a lot of transparency when they log into the sub account or into the GCP project to go and look at things, but they don't have, I guess, a lot of visibility over what is configurable, what are all the different options for my pipeline. That's still somewhat hidden away. So hopefully coming soon, we'll have a lot of that surfaced into the UI, and almost like a ETL builder style thing. So if you were a company looking to get a robust, highly available data pipeline, you'd be able to kind of click and drag components, set up a Snowplow collector in GCP that streams data into a Kafka cluster in AWS, and then set up a second collector in AWS, so that you kind of have that high availability, not just across regions or across availability zones, but across clouds. And that's really where I see the infrastructure going. And we'll need to go for that really true, robust, highly available structures. Banking on one cloud is not risky, but there's definitely a requirement, and will be more requirements to have that much more split and much more spread, so that you can really have that 100% uptime, taking all kind of worries away, that if Amazon has a glitch, or GCP has a glitch, that's not going to suddenly stop your pipeline from working. It'll still keep carrying on. It's just all that extra failover. The other big big changes, and I sort of touched on this with, when we were talking about batch processes or ephemeral EMR processes, that a lot of the, or if not all of that, will be moving to streaming architectures quite soon. So where we're currently, there are still some batch processes left. Snowplow will be moving to kind of 100% streaming, which we're very hopeful will result in not only better cost efficiency, especially at scale, but just much higher robustness and stability of the platform in general. There's a lot of difficulties with batch that we struggle to overcome. So, dealing with, what is my cluster specification between spikes is quite difficult. You don't necessarily always have, you can't auto scale a batch process in the same way that you can auto scale a streaming process. You can't, deal with the overhead of, okay, I've had a spike in traffic, I just need to grab a few extra servers, or I've had a spike in traffic for a really long time and I now need to get an enormous cluster to get through this backlog in a reasonable amount of time. Those kind of problems we're hoping will just go away with the migration to a full streaming architecture. It's definitely, though, on the flip side, more expensive to run on the lower scale. But I guess we're not really building for kind of low scaling. Or it is a big data architecture. It's a big data pipelines, and streaming definitely has a lot of cost efficiencies and performance efficiencies at scale, and that's I think where we want to take Snowplow next.
Are there any aspects of the Snowplow product or your management of the infrastructure and the service that you provide for it that we didn't discuss yet that you'd like to cover before we close out the show?
I think that's probably everything.
All right. Well, for anybody who wants to follow along with the work that you're doing or get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, I'd just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I can't see a big gap actually in the tooling. There's so much amazing tooling now for managing this stuff. It's just maybe the biggest gap is probably some way to harmonize a lot of the tools that are available now, which a lot of cloud providers are starting to do. But there's still there's almost too many options in managing data that it makes it hard to know which way you should go. Should you put everything on S3 in kind of Parquet? Should you put everything in Redshift? Should you put everything in Snowflake DB? Should you put everything kind of everywhere for different business use cases? I think there's just no silver bullet. There's nothing that solves all of these problems, and there might never be. But there's just such a wealth of options that it's quite hard to pick any one option. I don't know if that's a good gap or if that's just a factor of too much choice.
Yeah, it's definitely something that continues to be a problem. Is the paradox of choice, particularly as we add new platforms and new capabilities to the overall landscape of data management.
But there's a lot. It's a lot better than it used to be. That's for sure. So it is,
Certainly. All right. Well, thank you very much for taking the time today to join me and discuss the work that you're doing at Snowplow and how you're managing the infrastructure and automation around that for all of your different customers and the private SaaS nature of your business. It's definitely an interesting area that is something that doesn't really get a lot of attention as far as how to manage the underlying infrastructure for these data products. So thank you for all of your time and effort on that front, and I hope you enjoy the rest of your day.
Thanks, Tobias. Cheers. Bye.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.
La 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 la